Welcome along to topic 2 of computer programming, and this topic is on stages in programming and syntax and semantics. So it's quite important that we understand that when we're programming something, what we don't do is we don't just start programming and just hope for the best. And we can do that, but generally there's a process. And if a company, for example, were paying you to do programming, they probably wouldn't want you to be just diving in there and just making stuff up. So there are some stages in programming, and we have here this programming process. So probably the two most important stages are at either end of the spectrum here. Defining the problem and documenting the program are probably the most important things. So first of all, defining the problem. So if I said to you, right, if you were trying to add two numbers together, okay, and you were doing, let's say, number 1 is equal to 5, okay, and number 2 is equal to 4, okay, and if I try to do number 1 plus number 2, and let's just do answer is equal to that, we get an error, okay, because these two don't work. Now that's just a simple example. Because I've put this one in quotes here, this won't work. So at the moment we can see what the problem is here. The problem is unsupported operand type. So an operand is just something either side of an operator, and so we've got the add operator, the plus sign, and we've got these two operands, and it's saying that I don't support adding a number to a letter. Okay, it supports adding two letters together and it supports adding two numbers together, but it doesn't support, you can't add, if I said to you hello 5, what's the total, what's the sum of hello and 5? You couldn't say the sum of hello and 5 is 6, because it's not. Okay, you could say it's hello 5, but then that would mean you're treating 5 as a string. Okay, you're treating 5 as a letter then. So that's just a simple problem there. So often when people get stuck with programming, they're stuck because they can't identify the problem. And if you knew exactly what the problem is, okay, so if we do here, okay, print, and then we check the type of number 1, okay, it's going to say it's an integer, and then if we check the type of number 2, it's going to say that it's a string. Okay, so we can easily just change number 1 to string, and they'll join together. Change number 2 to integer, and they'll join together. So the most important stage at the beginning is actually figuring out what the problem is. Okay, so often the first thing you'll do is you'll meet with a client and sit down and talk about what it is that they want to do. So they might say, we've got all these strings and we want to add them to all these numbers. Is that something you can do? And you would just say, no, we can't, no, sorry. And they'd be like, right, bye then. And that would be the end. But let's say they said, is there a way we can change these strings and these numbers into strings to add them together? You'd say, well, that's a different problem, and yes, I can probably help you with that. So what we do is we produce a written agreement about what the client actually wants. So a good analogy is if you were designing a website. It's quite common that businesses will want websites, and they might say to you, oh, you work in IT, could you make me a website? And you might say, okay, what kind of website do you want? And they might say, I just want a simple one-page website. One page, it just says my opening hours, come down to the shop, a picture of the shop, and that's it. And you might say, okay. And so produce a written agreement. You'll say, I'll do that for you for £85, all right, and I'll have it done for you by tomorrow. So you go home, you make them a simple one-page website, you say, right, there's your website done, and they're like, but would you be able to put a booking system on there so people can book appointments? And you'd be like, well, that's not in the written agreement, that's well beyond the scope of what you asked me to do, that's going to cost more money. because you want me to go and make you a booking system. We're going to need to have a database and some kind of calendar integration. That's a different project. Okay, so the requirement specification just lists the functional and non-functional requirements, but also defines the scope of what it is you're going to do. So you don't want to try it to, you don't want to, there's a concept in project management called scope creep, where the scope keeps increasing as you do the and then they're like, oh, but can we have an SSL certificate? And you're like, well, you never asked for that either. That's another couple of hours of my time to set that up. Okay, so there's a kind of structure. This is an advisory structure. We should have in the requirement specification the functional and non-functional requirements, and it'll establish a basis of how long you think that the project is going to take. So if you imagine like an Edinburgh style project, if you sat down in 2008 with the company who were going to put the trams into Edinburgh, and you said, so how long is it going to take? Ocean Terminal to the Gyle, how long are the trams going to take? They'd say it's going to take 2 years. And you'd be like, okay, so it'll be done by 2010 then. And they'd be like, yep, it'll be done by 2010. You'd be like, perfect, and how much is it going to cost? And they'd be like, it's going to cost 100 million. And you'd be like, right, there you go, there's your 100 million, see you in 2 years. So 2008 plus 12 plus 2, 14 years later, here we are digging up Leith Walk. So you can see that that's well beyond the scope of what was originally agreed. Alright, so you imagine if you agreed to do a website for someone for £500, and you said it would take a month, and then 14 years later you're still working on the website, they'd probably be quite annoyed. They'd be wanting a refund. So here's a suggested structure for a requirement specification. An introduction that states the purpose of the program, the intended audience, intended use, the scope, any definitions and acronyms. So, if it's, let's say for example, the program is specific to an industry, you might say, oh, these are some abbreviations that are important that we're going to use, we're going to discuss in the document. A description with some user needs, and then functional, non-functional requirements. Okay, now you need to actually write one of these for the assessment for this subject at the end. Okay, so that's why this is in this part of the subject. So honestly, it's not a very difficult thing. It's just a Word document with some headings in it, and it just says what are the requirements of the program. Okay, so I've got a little graphic here. What the customer really needed is a tyre. How the customer explained it was some pieces of wood. How it was documented, no documentation, and how the programmer wrote it was like that. So these things can be different to what are expected when they're actually produced. So if you sat down and actually discussed the project before you started it, it would probably be a better idea. Going back to the trams, I don't understand why they're trying to do all of the tram line at the same time. Like, why not just do it in increments in an agile way? So, for example, they should have started it at the airport and said, right, we're going to go from the airport to the Gyle and see how that goes. And then they could do maybe the Gyle to the next bit and eventually get to York Place where they are now. The target should be to get from York Place down to, say, the top of Leith Walk. The target shouldn't be to go from York Place and dig up then the whole length of the tram line all at the same time and drag it out for years. I just don't understand why you would do it in that way. It seems very strange. Moving cones around and like rerouting the bus and all this kind of stuff. So I feel like things should be approached in a more agile way, especially in software. So ideally what you want to do is you want to work in short sprints in software. You want to say, okay, we're going to do this, and then we'll stop and we'll think, how did that go, and move on. Okay, so the second step, after we have our written agreement down, what we're going to do, alright, you've signed it, they've signed it, we're all in agreement, how long it's going to take, what they actually want, what the scope is. Then we go and start planning out. Now let's say, for example, we know we're going to write a program that calculates the balance on a credit card or in a bank account. This little notation here with the greater than symbol is called a decomposition. So what we've actually done is broken the problem down into smaller steps. Okay, so the first step here, right, if we want to calculate the interest on a credit card, we need to know what the balance is on the credit card. So there's step one. Then we need to know what the actual interest rate is. Then we need to calculate that interest based on the balance, now that we have those two. Then we would add the balance to the interest, then we'd return the total. Okay, so that's just a little way that, not a credit card, a savings account. A credit card would be the other way around, wouldn't it? They'd be taking the interest off rather than adding it on. So once you've got these steps, you can put these steps together into a flowchart. So we have here this flowchart. Now the flowchart is a kind of standardized set of symbols that we can use to plan out to show a program running. Okay, and the flowchart, we have this symbol here, this oval symbol. Oh, and the oval symbol where it says start end, all right, is called a terminator. Okay, like Terminator 2. So the terminator is where it starts and ends, where the program terminates. Okay, then if we have a process in the program, that's done with a rectangle. Okay, a decision is done with a diamond, and this is sometimes called data, but I/O, anything that's input or output to the program, is called is put in this parallelogram shape. Okay, so these standards are set by the American National Standards Institute and the British standard 4058 1973. It's a good pub quiz question, that one. What is the British standard for flowcharts? That would be 4058 1973, wouldn't it? Of course, for 1 point. Alright, so you can remember that one. Who standardized the American flowcharts? That would be the ANSI. So there we go. Right, so here's some examples. So here we have one where we've lost something. Okay, now these are just examples I found online. I didn't actually draw these. I can't take credit for them. They're just very simple examples. So start terminator, then we have a process, look for lost item. So if you lose your keys, for example, you'll start at the beginning. You've lost your keys, your car key or your house key. First stage, look for item. Now, my granny would say at this stage that you should pray to St. Anthony, the patron saint of lost keys. But in this flowchart, what we're going to do is we're going to say, did you find it? And then we have a decision. No. Do you need it? Yes, because I won't be able to lock the door or open the door without it. So go back to the look for lost item stage. And then, did you find it? Yes, I found it. Stop. Okay. So another one we have over here. Lamp doesn't work. Lamp plugged in? No. Plug it in. Yes. Is the bulb burnt out? Probably unlikely these days because we're using these energy saving light bulbs. So replace bulb or repair lamp. Okay, and it's also possible that we might have to change the fuse, maybe, wiggle about with the wire, try a different socket. I didn't add any. I'm not wanting to add any extras to it. So here's one for shopping. All right, for all those people who love shopping. Start, pick up item. Does the item spark joy for me? No. Throw the item away. Yes. Keep the item. Not a very good one, that, to be honest. I should probably delete that. Terrible. Okay, so there's just some examples of some simple flowcharts. Right, so let's say we now have a decomposition, a flowchart, a requirement specification, loads of documentation. You practically know what the program's going to do now. Writing out some pseudocode would be another stage. So pseudocode is not executable by the computer. Pseudocode is just an English-like non-standard language that you can write out. Okay, so I've got some examples of some pseudocode. If student grade is greater than or equal to 70, print passed, else print not passed. Okay, start program, enter two numbers, A and B, add the numbers together, print sum, end program. Okay, those are some examples of pseudocode. So it it's not executable by the computer, but it gives us an idea of what we're going to try and do. Now this is the point where we decide what language we're going to use. So we're going to use Python, then we can take our requirement specification, decomposition, flowchart, pseudocode, and start coding the program. And all that involves is translating the solution into a programming language. But at this stage, we actually know what we're going to try and do. We haven't just jumped in and been like, right, let's get started. Start, let's run, oh, it didn't work, okay. Next idea, okay, that's not working either. We don't just jump in and start doing that, because if we do that, then I feel like we're going to get lost a little bit. So coding the program is where we select a specific language. And then, once we've coded the program, we test the program. And in the next topic, next week, talk more detail about testing. There's lots of jobs actually in Edinburgh in testing. So if testing seems like something you might be interested in, it might be a good idea to think about it as a possible career. So in testing, you get other people's programs and run them and try to see if you can find problems with them. Okay, and there's all sorts of different types of testing you can do. So I know I've got a couple of friends who are test engineers, and there's quite a good job market locally for them. So you can, there's all sorts of different types of testing. As I said, I'll go into it in more detail in topic 3, but most programmers will get used to the idea that programs are going to have errors. Okay, so you have a testing department, or a testing person, a test manager. Sometimes they're called QA, quality assurance, and their job will be to check that the program runs in the way that you want it to run. So let's say you add a new feature to a program. The testing department would probably want to check that you haven't broken several old features. So I've given you this brilliant new thing. When you drag the calendar, a little icon pops up, and they'd be like, brilliant, but you broke 5 other things in the process of doing that. So you need to go back and change your program so that it doesn't break everything. So I think that's actually called regression testing. Make sure that you haven't broken things in the past. Okay, now finally, the most important part of the program, the most important part of networking, of cybersecurity, of IT, the most important part of anything is documentation. So what's the most important part of systems administration? Documentation. Programming, documentation. Network engineering, documentation. Digital forensics, documentation. Okay? If there isn't any documentation, then your program is just a black box. Okay? It's a box that does something and no one knows what's inside it. That's what we mean when we say it's a black box. So turnover is high in IT, and it's likely that you're going to move to a different job. And if you've written a program that does something that's very good, that's great, but you need to write it in a way that other people will be able to use it in future. Okay, so documentation would be things like user guides, the flowcharts, the test records, and then internal documentation with comments and things is also quite useful if someone is going to add new features to the program. So programs without documentation are quite difficult to use, aren't they? Because someone in the future will have to go and reverse engineer everything you've done to figure out how it works. So that's the most important and final stage, the documentation. And well-written documentation, like a GitHub page with a README, would be a good example of that, or a nice Word document with properly numbered sections, a PDF, some kind of wiki would be good. There's all sorts of ways you can document stuff. So that is stage 5, the final stage of the programming process. So, oh, I put that animation in there just to just to enforce the fact that it's quite important. Right, comments. So in Python, if we put this hash symbol at the beginning, it's sometimes called hash, sometimes called a pound sign, hashtag. I think the real name for it is actually an octothorpe, is the correct name for that. You put that to the beginning, you're telling the Python interpreter to ignore that line. Okay, so another name for these comments is internal documentation, because they're inside the program. Okay, so here's a couple examples of comments. Just this program prints hello world, this program adds two numbers together. Okay, and Python, as it's reading the program line by line, it won't interpret these lines, it'll ignore them. Okay, so that hash tag at the beginning tells it ignore this line. Okay, so the final part today is about syntax and semantics. So what we actually have over here, see this name error and invalid syntax. These are examples of syntax errors. Okay, so syntax errors are usually quite easy to find, and the program will pick them up, and it'll even give you a little reason why it's a syntax error. Okay, so up here the other error I had, type error, unsupported operand type, can't add integer and string together. Okay, down here, name error, start is not defined, because I just wrote the word start. No such thing as start, what are you talking about? Okay, so the syntax is which groups of characters and symbols are well formed that the computer understands. So for example, this strange thing that I've written here is a syntax error. Okay, car hour walk fits the syntax, right? Car hour walk fits the syntax of English, but it doesn't make sense. Okay, so that's a different type of error. Quiero pagar is syntactically valid, but only in Spanish. No, if you send that to someone and they didn't know Spanish, they would be like, what are you talking about? So it doesn't have any meaning in English. So there's another type of error, and that's called a semantic error. Okay, so I are cold, like, doesn't necessarily violate the syntax of English. Okay, I's a word, R's a word, and cold's a word. Okay, but it's breaking the semantics, because we don't really get what you're saying there. And so I've got this little graphic here that I found. Call me a taxi. So the lady says back, do you want me to get you a taxi, or do you want me to call you taxi? Like, is your name taxi, or do you want me to order you a taxi? So English can be ambiguous, and these are called the semantic errors. Alright, now the worst thing that happens in a program is if we create a program and it's given us an answer, but the answer's wrong somehow, but we can't tell, like, it's given us some output, but it's not the right output. That would be an example of a semantic error, and that's much more difficult for the computer to pick up, because according to the computer it's doing the right thing, it's doing what you told it to do. So the syntax errors are easier to spot, because it's just things like you missed a bracket out, or you missed, name is not defined, or something like that. Now, the good news is, in programming languages, every statement only has one meaning. Right? You can't have call me a taxi in programming. Okay, you can't have ambiguous statements. The other good thing about this language Python we're using is there's only around about 30 words in the whole language. I think it's 35 words in the whole language. So all you need, if you think about English or Spanish or Polish or French, there's a lot of words to learn just to get going with the basics there. Python, there's only 35. So you could probably learn Python in one day. If you really wanted to, you could write them all down on a piece of paper, carry them around with you. Some of them are really easy as well. Print, in, is, as. Okay, so which errors are worse? So syntax errors are fine, because the program will just stop when it hits a syntax error, and it'll say syntax error here. right? And it'll try and tell you what it thinks the problem is. Static semantic errors are caught when the programs run, but they can make the program behave unpredictably. Programs don't have semantic errors, so you would never see a computer saying that's a semantic error there. You've misinterpreted me. The worst situation is when the program produces an answer, but it's not the answer that we intended. Okay, so Python errors. Python is an interpreted language, so as it runs, as soon as it hits an error, it'll stop. It'll say, nah, sorry, line 300, can't deal with that. So that's sometimes why it's called a Python script, because it's read line by line like an actor would do. And so that is topic 2. Now, what I'm going to do is I'm just going to do a little bit of a demo here. We have a library called IPY-draw.io. Just give me a little second. I'm just going to pause this recording just now just to sort out my various windows. So let's just... I found this online. This is by someone called MK Low, right? And this is a fantastic guide. Now, I was going to adopt it and change it, but to be honest, I'd rather just give credit to the original author. It's an excellent piece of work. And it explains these flowcharts in a little bit better detail than I did, because as part of the assessment for this subject, you need to be able to create a flowchart, and it tends to cause people some problems later on down the line. So, first of all, a flowchart is a way of visually representing an algorithm. Okay, and we spoke about algorithms last week. An algorithm is just a recipe or a set of steps, right? So you think of an algorithm like a cookery in a cookery book. Those are algorithms, okay? Flowcharts are strict because computers need very specific instructions, and each flowchart contains a small shape. Now, this shape here, the terminator, as I said, Terminator 2, contains start or end, and that's how. Sometimes you see that as like an oval shape. Okay, it's not always this rounded rectangle. Then we have this I/O shape. Okay, and oh right, hold on. I thought it was. Right, okay, let's go back to the start. Right, so this guide here by MK Low, I found this online and I didn't want to change it because it's a very good piece of work. It's very simple, so I just wanted to give credit to this MK Low chap for putting this together. Now, what is a flowchart? Right, so a flowchart is a way of visually representing an algorithm, and as I said last week, an algorithm is just a recipe. Okay, so here's our shapes here. The rounded rectangle is called a terminator, right? And that's start or end. A parallelogram is for I/O, something coming into the program or something being output from the program. So print yes or print answer, you'd have an I/O. Then process is put in a rectangle, okay, and a decision is in a diamond. So scroll down a wee bit more. How to draw flowcharts. So we have this thing called draw.io, right? Believe it or not, it's a website. But what we can actually do now is we can actually incorporate draw.io into the Jupyter Lab environment. So if you give me a second, I'm just going to open a new terminal and I'll show you. So in your command line, the command to run, we're going to get this library here, is pip install ipdraw.io. Right, so what I'm going to do is I'll fire this into the chat just now. I want you to give it a wee shot. So I'll just show you, right? Pip install ipydraw.io, like that. Now, it's going to say to me I've already got it installed because I already do, but I'll run it anyway just to let you see what it looks like. Requirement already satisfied. So if we do this, right, what this is going to do is this is going to incorporate the draw.io environment into Jupyter. So if I just make Jupyter a little bit bigger here, once you've installed IPY-Draw.io, inside your Jupyter launcher, you now have a button called Diagram, and you can click Create New Diagram, and it gives you a diagram creator. And I'll just move this along a wee bit. You can even go here and you can open up Flowchart, and look, here's all the flowchart symbols here. So, and if you hover over it, it tells you what it's for. Now there's more than just the 4 basic ones, but we only really need the 4 bits. So look, this will be the terminator. So we just grab the terminator, pop it there, okay, and then we can, so let's say we're going to have some input data, pop that there, and then we can just hover under the terminator and click that arrow, and it will join the two of them together like that. We can click on here, we can change the color to that, and we can double click and we can do start, okay, and we can click here and we can change the color to blue and click apply. That didn't work because that was the text. Click there we go. Okay, and we can say like input number, okay. So basically we can do all of this now just from within the browser, with this IPY-Draw.io plugin to Jupyter. Okay, so we used to have a separate Draw.io environment, but now everything can run within this one Jupyter Lab environment. So let's go back to this presentation here. So here's an example, getting a book out of a backpack. Start, then the process would be open the zip, then an IO, remove book from bag, so output book, then end. Here's so this is explained in more detail. Okay, opening the zip is a process, so that goes in the rectangle, although they've called it a square. Say it's a rectangle. Removing the book is output, so that's in a parallelogram, and I finish all flowcharts with a terminator symbol. Only ever contains the word end. Okay, only ever contains the word start. Personally, I don't like capitalizing everything, so I write start like that, okay? But some people like to write start like that, okay? No one's going to argue with you. I just don't like capital letters. Right, so here's determine if I have picked up a red pencil. I actually have a red pen right here. So pick up a random pencil. Is the pencil red? Yes. Say the pencil's red. Is the pencil red? No. Say the pencil's not red. So there it is, explained in more detail. I'm not going to go into that too much because it's exactly the same as what I just said. Here's one to determine if a kettle has boiled. Turn on the kettle. Has it boiled? Pour water into cup. Now, something to think about here is we have these two types of knowledge, imperative knowledge and declarative knowledge, okay? So the declarative knowledge here would be, what is a kettle? Okay, what is boiled? But the imperative knowledge, the steps, would be like turning it on. Do you know how to turn it on? Okay, do you know how to pour the cup? So that's how we can divide those two types of knowledge that we spoke about in topic 1. So there's a little bit of an explanation for this, and I'll make this document available to you. Here's one about a game with a red apple that's getting more and more complicated, but it's following the same pattern as before. So have a go. So what I'd like us to do now is install. I'm going to stop this now, and we're going to try an exercise. So let me just stop this recording here.